Good morning. Today we'll be taking a look at this 2014 Ford Explorer and the various components surrounding the fuel system as far as the fuel injectors, fuel rails, that stuff go. So let's go ahead and take a look at it. So as we can see here, this is a 6-cylinder engine. 3 of the injectors are right here. From closer look inspection upon the lines and stuff, there is no return line. So this is going to be an electronic returnless system. And according to the owner's manual, the fuel pump relay is going to be this guy here in the corner. So we'll go ahead and pull that out and then start the vehicle up. Alright, so we got the code reader plugged in here, and with this vehicle we can see Christmas came early because it's probably got about every code in the book being thrown at this thing right now. Alright, so here is the fuel pump monitor percent, key on, engine off right now. And as you scroll down here, you can see the fuel rail pressure, fuel system status, all that stuff. So key on, engine off right now, so we'll go ahead and fire it up. And as you can see here, we're still in closed loop status because the vehicle is still cold. It hasn't reached operating temperature. So as the vehicle warms up, I'm sure we'll start to see that adjust. So we've been sitting here a while. It stays in closed loop, but when you turn the car off and then key on, engine off, it will go to open loop. You can see we tried it once here already. And you can see it's dipped down here again, but then when you go to start the vehicle, it will just go right back to closed loop. And there it is. But it is up to operating temperature. So it's kind of interesting that it is switching back and forth like that. But we'll go ahead and continue on. So we figured out, and obviously when you think about it, it makes sense. Obviously at idle operating temperature, it's going to be closed loop because the ECU is just set to certain parameters. But when you put load on the engine, like rev it up or something like that, you can see it does blip into open loop from closed loop. There it is again. So assuming if we were able to take the car out and drive it, it would be in open loop mode. But considering that we're just sitting here at idle, it's going to stay closed loop. But you can get it to switch back and forth if you keep kind of giving it some revs. Today we will be taking a look at the fuel rail on this 2017 Sonata. We've already taken off most of the electronic wires and stuff. Fuel line here, depressurized the high pressure fuel pump because this is direct injection. Returnless system. We're gonna take off this intake manifold, and the injectors in the fuel rail are all located on the manifold there. So we go ahead and take all these bolts out. There's a couple bolts up here, and there's more on the bottom down there. So we'll go ahead and put the car in the air and see if we can get any easier access. So here we are. We have the manifold off. The fuel rails are a lot more visible and accessible. As you can see, our assumption was correct. This is electronic returnless system here. High pressure direct injection. High pressure fuel pump is there. So the intake manifold is off. All the connectors are disconnected. Injectors are unplugged. The fuel line is off now. Assuming that this fuel rail has probably never been pulled out of this car before, it is just like it's super tight in there. So we're just trying to pull the fuel rail off there now. There's just a super tight vacuum in there where the injectors are. So, but it's coming out. So we got the fuel rail off here. She's definitely a squirter. So we got the fuel rail out with 2 of 4 injectors. 2 of them did not want to come out. All the fuel ended up just spilling out of it anyway. There wasn't that much left, but we got it all cleaned up. It's all good. So we're gonna look up various parts and stuff because oh, there you go, we got one out of there. So you can see here the metal clamp and stuff that keeps it in the in place there. And supposedly you need a special tool to put them back in. We'll do some more research on that. We're also going to do some research on if you are able to just replace these gaskets here, because supposedly these are just a one-time use only. So I don't know if you have to replace the whole gasket or if you end up having to just replace the whole injector. But yeah,
I get that.
that boy stuck. So all 4 injectors have been removed successfully, with a little bit of some sweat and tears.
No persuasion.
No blood, surprisingly. No blood.
Yeah.
But they're all out. A couple of them are real tough to get out of there. You can see a lot of corrosion and stuff built up here. So I'm sure that doesn't help. They've probably never been pulled out of the car before. So from what we could see on all data here, you can actually replace just pieces of the gasket here on the injector. Obviously we're not going to do that to the lab car, but it is a good thing to know on these direct injection injectors that you don't have to replace the whole injector and pay for a whole new $150 injector. You can just reuse the gaskets, because by Hyundai they say that these are one-time use only. So it is nice to know that you can replace them. They mark them as individual parts on all data. Once again, here we are back at the Hyundai.
Fuck.
Dropping tools. We you can't bench test direct injection injectors because they're not really meant to be hooked up with 12 volt. If theoretically, if you could bench test these, it'd be interesting to see, because you could see the little holes on the injector itself where the fuel is going to spray out. There you go, 6 holes on each injector. And there's so much carbon buildup and stuff on these that I'd be interested to see the flow rate and the flow pattern on some of these because of how dirty they are. Before we put stuff back together, we're cleaning out the ports and stuff for the fuel the fuel injectors go into, because they were super dirty. They had probably never been taken out before. So we went ahead and cleaned those, and then we're gonna grease up. Just put a little bit of grease on these gaskets here to help them slide in and out, because they were super stuck in there. And when we pulled the rail out, like you saw earlier, we had a couple injectors get stuck actually in the ports. So we're gonna help the next guy out and clean it up for him. That way it's not so hard next time. So after cleaning and greasing, we are now attempting to reinstall.
Oh yeah. Here, you press that side out first. Wait, I heard a click.
So we're putting that in. We got it most of the way in, and then we're trying to see if we can't pull it in a little closer with the bolts here. So now we got the fuel rail installed. Tighten up this line here with the open-ended, and then we'll plug these harnesses back in. So now we have all the plastics back together. It's all nice and pretty. PCM's fried, but don't worry about that. Everything else is good. So we got that Hyundai all put back together. Now we've hopped onto this Ford. We're gonna actually do some testing now, because that unfortunately that Hyundai, while we were able to use it as a good example as far as taking off all the components and showing you you know, the fuel rail and the fuel injector, unfortunately it didn't get any power to the PCM at all. I'm pretty sure the PCM on that car is fried. So now we got the picoscope hooked up, testing for amps here on the fuel injector wire, so we can actually show you guys some measurements with a car that is actually running. So here we have the car idling, just under normal idle here, and as you can see on the picoscope, you are getting a reading on the ejector here. You can see it slightly ramp up and then just immediately go off. I'll see if I can't get it paused here for you. So as you can see here, the amps kind of ramp up and then go off, which is what you want to see with an injector there. And you can see it in real time. It goes so fast. I know it's hard to see. And I have it slowed down a lot already. But you can see it going by there. Looks normal. So now it's at idle. So if we go ahead and give it some gas, we'll see what the signal will do. So you can see it ramp up. You can see the peaks get a little higher. Seems to be operating normally. So it's a good thing and a bad thing. We got a lot of content for this video, so I don't want to make it super long. But we'll run some more tests here in a different lab. But I'm just gonna call it quits here for this one. Definitely got some good footage here, got some good experience, and until next time, thanks for watching.